Joseph, you see him in a Puneri pagdi and a shawl and all that. We had
I
a
just lost
privilege
the sound.
we had a privilege of felicitating him when we attended the International Space Development Conference from 23rd May to 28th May in Los Angeles. And Joseph has had a lifelong interest in human settlement of outer space. He has been president of the Sacramento L5 Society since 2007, and he is the chairman in our language, and in American language only chair, of the National Space Society Chapter Assembly since December 2017. A third generation invention and creative, his grandfather founded the Pasadena, California Philharmonic Orchestra, and his father studied at Caltech in California. Joseph is the owner of 2 US patents on heat engine design and the recipient of a related California Energy Innovation Small Grant Award. Joseph and Donna, his wife of 34 years, are presently happily retired in Sacramento, California. Let me tell you about this National Space Society Chapter Assembly. National Space Society in USA is the biggest space-related organization. It's a non-profit organization, and it has got chapters all over United States as well as some parts of the world. We have in India the first full-fledged chapter of NSS in Nashik. All the people representing chapters, mostly the presidents of the chapters, we have an assembly, chapter assembly. In our local language, we can say like a union of all the chapters, and we are responsible for discussing of what is going to be the future of space technology and all other things. And the chapter assembly always advises the National Space Society for their different agendas, different proposals, and all that. So Joseph Bland, in short called as Joe, he is the president of this chapter assembly. And today he is going to make a presentation for about 45 minutes, and then we will have an interaction with him. And then at 7:30, there will be an online chapter assembly meeting, Zoom meeting, where about 30 people from all over the world, from all over the chapters, from different countries, and mostly, of course, USA, they will be joining online, and there will be introduction of each one of them, and then they will be discussing, rather as a panel discussion, panel discussion about space unites the world, as that is the theme of this year's World Space Week. So all these people are space technology experts from different parts of the world. Now, I welcome Joe. Can you take over and you can start your presentation.
Thank you, Avinash, very much.
Thank you.
Well, good morning, folks. My name is Joseph Bland, and before you is a list of the topics I am planning on getting through this morning. I'm here today representing my chapter of the National Space Society, the Sacramento L5 Society. And I will be discussing a project that my chapter has been working on for the last couple of years. First, a bit of history. Our parent organization, the National Space Society, was formed in 1987 by the merger of 2 older space advocacy organizations, the L5 Society and the National Space Institute. The Sacramento L5 Society was one of the earliest chapters of the old L5 Society, and we began around 1978. Oopsie, sorry. We're going to try this again. I don't know what's happening with my computer. We will fix it very quickly.
Just press the bottom arrow.
Yeah, it didn't work today very well, but we'll do this again. All right. Here we go. Many people ask, what is meant by the term L5? The letter L in L5 stands for Lagrange point. So what is a Lagrange point? It in essence is a space that's defined by gravity fields of two gravitational bodies orbiting one another. Now, every two-body system in space has 5 Lagrange points. Hence, the L5 society is a society based around these 5 points. Now, this little sketch indicates the Lagrange points for the Sun and Earth two-body system. But the arrangement is the same for the Earth-Moon two-body system, and indeed for every two-body system in space. So the answer to the question, what is meant by the term L5 in Sacramento L5 Society, is a society in Sacramento that is based on the concept of the 5 Lagrange points. In Professor Gerard K. O'Neill's seminal paper, The Colonization of Space, published in 1974, he proposed establishing initial city-sized space habitats at Earth-Moon Lagrange points 4 and 5. A year later, the L5 Society was incorporated with Dr. O'Neill's goal of eventually building those 2 cities in space. David Brent Erickson of the National Space Society had this to say about the old L5 Society. It is difficult today to realize the excitement that was generated in the early years of the L5 Society. Every issue of the L5 News contained reports of new studies and progress in the field. L5 members at the time thought that they would really get the chance to personally live in space within their lifetimes. But we often hear the question, why send people into space at all? I'll see if I can explain. In mankind's distant past, our world must have seemed boundless. But today, we find that the world is shrinking, not because it has gotten physically smaller, but because humanity has gotten so much bigger. 50 years ago, when I was in college, the world's population was 3.5 billion. Today, it is 7.5 billion. If population continues to grow at the rate of the last 10 years, 50 years from now, we will add yet another 4 billion people. Put another way, when those of you in college now are my age, the demands on the Earth's resources will be 35% greater than they are today. And competition for any remaining resources will ramp up correspondingly, creating ever more stress and strain on the world's social systems. Fortunately, there have been visionaries who recognized that this process was at work and who strove to give humanity a way out. Professor O'Neill was one of those visionaries. It turns out that the resources of our solar system are truly vast. Using those resources, Professor O'Neill foresaw the possibility of creating multitudinous cities in space. As Professor O'Neill put it in The Colonization of Space, the ultimate size for the human race is at least 20,000 times its present value. Put another way, Professor O'Neill recognized that the boundless world the human race once enjoyed still exists. It's just sitting out there, waiting for us. So one reason for humanity to send people into space is to recreate the boundless world. But some of us have had a more personal reason. We wanted to live and raise our families there.
हे आपल्या शिवलिंगासारखं दिसतंय.
Hello? I'm sorry. So, some of us had a more personal reason. We wanted to live and raise our families there. And if we're now too old, then we want our children or their children or humanity as a whole to have that opportunity. In short, we want to contribute to the creation of Professor O'Neill's boundless cities in space, even if we can't personally hope to live in one. And yet, here we are, almost 45 years after Professor O'Neill published his paper, and almost 50 years after we last walked on the moon. What happened to the L5 Society's vision of city-sized habitats orbiting at EML 4 and 5? As it turns out, while there were good things about those two Lagrange points, there was also one unexpected and particularly bad thing. Space, we now know, is filled with a deadly sleet of radiation, including massive particles traveling at tremendous velocities. Some of these particles are radiating from our own sun, but some of the most dangerous ones, called cosmic radiation, are coming from all directions, the result of supernova explosions across the entire universe. We on the Earth, safe behind our planet's very powerful magnetic field, and only mildly affected by this, are only mildly affected by this radiation. Not so in space. Recently, the difficulty cosmic radiation poses for large-scale habitation of space was made crystal clear in a paper by National Space Society luminary Al Globus, in a paper called Orbital Space Settlement Radiation Shielding. The upshot of Mr. Globus's paper was that barring a major breakthrough in man-made magnetic shielding, EML 4 and 5 would require vastly more mass for shielding purposes than Professor O'Neill had envisioned. Why is that such a problem? One of the major reasons that Professor O'Neill picked EML 4 and 5 is that they are far more stable than EMLs 1, 2, and 3. Thus, a city built there will pretty much stay there and won't require much fuel to keep on station. However, EML 4 and 5 are a very long way away from any material resource. Those 2 points in space lie in the Earth-Moon orbit, with EML 4 leading the moon and EML 5 trailing it. Mathematically, each point forms one end of an equilateral triangle, where the distance from the Earth to EML 4 or 5 is equal to the distance from the Earth to the moon, and also equal to the distance between the moon and EML 4 or 5. As a result, with a huge increase in required mass for shielding and the long distance from the resources to make that shielding, the price of constructing space cities at EML 4 or 5 became much, much higher. Does this mean the dream of settling space is finished? Far from it. Space's frontiers will remain limitless when all other frontiers are gone. However, if we're truly serious about creating and living in space cities, we will need to reprioritize our goals. Because the corollary to Mr. Globus's radiation paper is simply this: some of space's frontiers are going to be far easier to settle than others. In August of 2016, my chapter published a paper on our website, sacl5.org, entitled Settling Space. In it, we rated possible settlement candidates for building viable cities in space. The conclusion of this somewhat crude analysis may surprise some. The moon fits more criteria than any other candidate. Note that this does not mean that the moon is in fact the best candidate for space settlements, since that determination would require a far more detailed analysis. Nevertheless, it does strongly imply that the moon is a very good candidate. Just recently, we were forced to make a major revision to our analysis. On June 1st of this year, a major dust storm began developing on Mars. By June the 12th, the lack of sunlight forced the Opportunity Mars rover, shown here, to be put into continuous hibernation. By June the 20th, the dust storm covered the entire planet. It wasn't until the end of August, 2 months later, that the dust storm began clearing. To date, NASA has not been successful in reactivating Opportunity. I guess you could say that's a lost opportunity. As a result, it is now obvious that Mars is a very unreliable place for any process that requires solar power generation on a continual basis. However, the moon also has a problem with energy, albeit not as serious as the problems on Mars and far more predictable. Because one side of the moon always faces the Earth and the moon rotates around the Earth once a month, its nights are 2 weeks long. That's a very long time to go without sunlight. Therefore, the question of powering the moon becomes a critical one. The ultimate goal of my chapter is to see cities built in space, and we believe the moon gives us the best chance of doing that. But it's a distant goal that would require progressing through multiple levels of required power generation. We have a suggestion for helping the moon move from the very lowest to the very highest levels of power generation capacity. We are proposing the establishment of a publicly owned lunar power utility, or LPU. And ideally, it would be in place from the very beginning of mankind's efforts to develop the moon. The main goal of a publicly owned LPU would be the establishment of reasonable rates for lunar power. These reasonable rates would in turn foster the development of lunar resources. Development of lunar resources would in turn help establish a foundation for massive lunar settlements. By establishing the publicly owned LPU very early, possibly even at the micropower level, continual growth in the production of power can be maintained. Over time, the LPU will utilize and coordinate multiple energy sources, much as utilities in the US are a mixture of nuclear, hydrocarbon combustion, solar, wind, and so forth. A key element of this proposal for establishing a publicly owned LPU involves adding prime lunar power generation real estate to the LPU. For example, the mountains on the rim of Shackleton Crater, located almost precisely at the moon's south pole, can be considered prime lunar power generation real estate and should be under the ownership of such an LPU. We can loosely define the power requirement levels as micropower, low power, medium power, and high power. During the moon's initial development phase, we'll start with micropower requirement processes and devices and progress our way up the scale. To power a full-size lunar city, a continuous power level will be required that measures in the hundreds of gigawatt hours. We contend that to achieve the high power level, we will require sooner or later the establishment of a publicly owned LPU. The medium power level is where we can expect to see humans beginning to seriously inhabit the moon on a permanent basis. We can measure this level in the hundreds of kilowatt hours to the tens of gigawatt hours. For this level, we're proposing the early on development of what we call the Lunar Polar Multi-Array System, or LPMS, initially proposed by chapter member Michael Abramson. At the concept's heart is the often proposed idea of using multiple polar mountains, possibly in the area of Shackleton Crater, to create a connected network or power grid that sees sunlight most of the lunar month. The LPMS grid begins small, with 2 or perhaps 3 connected solar power plants on the peaks surrounding Shackleton Crater. The LPMS then adds new solar power plants to the grid. Importantly, additional grid-connected solar power stations can be radiated out from the lunar poles in opposite directions simultaneously. As a result, at any point in time, half of these new power stations would always be actively producing energy and feeding into the grid. Consequently, establishing a LPMS at the lunar poles that grows outward in both directions simultaneously can be seen as an enabling technology for achieving moderate power levels and perhaps eventually the high power levels that are capable of sustaining full-sized cities. At the low power level, we might have a few relatively small human outposts, but most of the energy will be utilized by robots or automated outposts. These might be in the hundreds of watt hours to the tens of kilowatt hours per robot or outpost. Early mining equipment might fall under this level. This low power level is the level our chapter has been intensively analyzing for the last 4 years or so. It assumes power levels from the hundreds of watt hours to the tens of kilowatt hours. Our chapter's analysis began in mid-March of 2014 when chapter member Michael Abramson became involved in an informal discussion group at NASA's Ames, California facility. The NASA group was looking for low-cost ways to construct a lunar base. As part of our contribution to the group, our chapter undertook to analyze and rate by mass several different possible solutions to the moon's 2-week-long energy problem. One approach that I suggested for powering a moon base through the 2-week-long lunar night concerned the use of a solar-powered laser in lunar orbit and at EML 1 and 2. My suggestion was inspired by the work of 2 young college students, Akhil Kalapala and Krishna Sivaraju of Rajiv Gandhi University in India. I had helped mentor Akhil and Krishna when they were developing an entry called HelioAstra for the National Space Society-sponsored 2013 and 2014 International Sunsat Design Competition, an entry that ended up winning them first place and a $10,000 prize. Their basic concept involved beaming a dispersed laser beam from the geosynchronous orbit to an area just off the coast of India. The solar-powered laser will provide energy to desalinate water at a competitive price. I suggested to them that the same technology could be used by orbiting satellites on the lunar surface to power installations there through the 2-week-long lunar night. What you're seeing here is part of the video presentation these two young people put together for the contest. I was extremely impressed by the talent and work ethic of Akhil and Krishna. I can think of no better example than these two wonderful young people of the combination of talent, training, and tenacity that can be found here in India. In early February of 2015, my chapter had come close to completing our analysis for the NASA Ames Informal Study Group when we stumbled across a series of 91 slides on the internet. The slides detailed a NASA study from February the 26th, 2009, entitled NASA JSC Lunar Surface Concept Study - Lunar Energy Storage by Dr. Cheng Yi Liu and Jim McClanahan. In essence, NASA's conclusions agreed with our conclusions. Using lasers to broadcast energy to the lunar surface was a competitive idea. We immediately undertook to integrate the two studies. Importantly, there were some significant differences between NASA's approach to broadcasting laser energy to the lunar surface and our independent approach to the problem. The first major difference had to do with orbits. The 2009 NASA study focused in part on a fixed orbit laser system, FOLS, with a 1-meter collimating lens in a 16-hour elliptical orbit at a 45-degree inclination, with a maximum distance from the lunar surface of about 16,000 kilometers, creating an average spot diameter on the lunar surface of about 32 meters. We proposed a much closer circular orbit. For a circular orbit 1,000 kilometers directly above the lunar surface, a 1-meter aperture laser would have a spot diameter of 1/16 of the NASA study's average diameter, or about 2 meters. A brief word here about lunar orbits. The moon has the largest collection of mascons, or massive lumps of dense material on or inside the moon, of any known body in the solar system. These mascons create difficulties both for maintaining lunar orbits and for laser tracking. Eventually, 4 inclinations were discovered: 27 degrees, 50 degrees, 76 degrees, and 86 degrees, that produced highly stable frozen orbits. For this reason, our proposed low orbiting system would need to follow closely these lunar orbits. Fortunately, the 86-degree inclination is almost perfect for the orbiting lasers needed to power initial polar installations. There was a second fundamental difference between the NASA approach and ours, and it was actually fundamental to why we chose to orbit the lunar surface far closer than the NASA study. For a 5 kilowatt-hour delivered system, the NASA FOLS approach, which only powered the laser when it was both in sunlight and in sight of the lunar surface target, required over 2,625 kilograms of power storage and another 1,372 kilograms in collector mass on the lunar surface. And that was a production, as I said, of 5 kilowatt hours, continuous. Using lithium sulfur batteries would drop the battery mass to about 1,050 kilograms. However, it would still have required sending a total mass of about 7,333 kilograms to the translunar injection or orbit around the moon. Early on in our analysis, I had proposed storing nearly all the solar energy in orbit and using that stored energy to power the laser system when it was in shadow. As a result, our 5 kilowatt delivered lunar orbiting laser system only required 90 kilograms on the lunar surface. And while our system required both a substantial battery and a larger laser and radiator than the NASA approach, our total mass to translunar injection would only mass about 1,667 kilograms, or less than a quarter of the total mass to translunar injection required for the NASA system. There is yet a third major difference between our analysis and the NASA analysis. NASA had studied and rejected the possibility of beaming power for the vicinity of EML1 and EML2, the two Lagrange points of the Earth-Moon system that were closest to the Moon. NASA calculated that using a laser with a 1 meter collimating lens, the beam spot from EML1, when it reached the Moon, would be about 119 meters in diameter. From EML2, the spot would be even larger. For the 5 kilowatt hour system NASA was studying, that was clearly impractical. Interestingly, a 1993 NASA study entitled Power Transmission by Laser Beam for Lunar Synchronous Satellite has suggested a potential solution, but apparently it wasn't taken into serious consideration. Perhaps that was because of the high mass of the collimating mirrors estimated in that study. Fortunately, prior to our stumbling onto the NASA study, chapter member Roger Arnold had come up with an elegant solution to the problem of high collimating mass. Use a thin film lens, such as a Fresnel lens, which is pictured here. We call the thin film lens approach aggressively collimating technology, or ACT. Recall that NASA had projected a laser spot diameter on the lunar surface of 119 meters. Using ACT and assuming a 10-meter diameter thin film collimating lens, we had previously calculated that for a laser orbiting at EML1, the beam spot could be reduced to a diameter of about 12 meters, or 1/10 the diameter assumed by NASA. All right. Well, I missed the slide here. I'm going to move on. And just to prove there really is very little new under the sun, here's a slide from our January 1999, from January 1999, where someone appears to have been thinking along somewhat similar lines to our chapter. My guess is that this particular ultralight frame could easily have held about a 2-meter diameter thin film lens, and the whole affair would have negligible mass. A fourth difference between our chapter's study and the NASA study, concerned orbiting in the vicinity of EML1. Typically, that is done these days with what is called a halo orbit. These orbits, however, can be on the order of tens of thousands of kilometers in diameter, orbiting perpendicular to the line between the two bodies in space. In this case, the center of gravity of the Earth and the center of gravity of the Moon. The ISEE-3 satellite, a joint NASA and ISRO ESA effort, initially used a halo orbit around Sun-Earth L1. Our chapter theorized several techniques for keeping a spacecraft within a few thousand kilometers of EML1. This included some interesting techniques for avoiding the use of reaction mass. The first concept, again suggested by member Roger Arnold, was to essentially surf the EML1 point, which is in constant motion due to the moon's elliptical orbit around the Earth. Two other ideas reduced and potentially eliminated the loss of reaction mass at all. The first was to use solar sails, shown here. The second was to use shifting gravitational differentials via use of what we termed a gravity winch. Intriguingly, both those concepts appear to have been anticipated much earlier. In his 1963 paper, The Stabilization of an Artificial Satellite at the Inferior Conjunction Point of the Earth-Moon System, Giuseppe Bepi Colombo refers to both these ideas. Known as Bepi by his friends and colleagues, Mr. Colombo is best recognized for his calculations that ultimately led to the success of the Mariner 10 mission through the use of multiple flybys to get the spacecraft into a resonant orbit with the planet Mercury. In fact, the joint ESA and JAXA Mercury mission, scheduled to launch this month, is called the Bepi Colombo mission. And this is a picture of that proposed or completed satellite. In his paper, Mr. Colombo says, "It is obviously important to be able to keep an artificial satellite stable at the inferior conjunction point, L1, of the Earth-Moon system, while using the minimum amount of momentum," which is to say reaction mass. "We shall study some devices to stabilize a satellite in a region around L1 without using momentum. The devices considered are a solar sail of relatively small dimensions and a mechanical autonomous device." To my knowledge, neither of Mr. Colombo's proposed devices has ever been tested. Finally, let us turn our attention to the micropower level, which we can define as less than a kilowatt down to a few tens of watts. The micropower level will power the initial robotic explorers and automated outposts on the moon. For example, the Spirit Mars rover only required 25 watts of continuous power to function. For this level, For this level, we're proposing a drastically scaled down lunar orbiting electrically powered laser system, or LOELS. Since there are many entities planning to launch instruments to the lunar surface over the next several years, any one of these can become a target for an orbiting laser, which would only need to add the orbiting laser's inner surface components to their instrument to have access to power throughout the lunar night. Assuming a rover similar to the Mars rover Spirit, shown here, a lunar rover would mass about 180 kilograms and would require only 23 watts per hour. Due to the intense cold of the lunar night, we might want to double this for our rover to about 50 watt hours. We can calculate the period of a 1,000 kilometer lunar orbit as equal to 3.2 hours. We will assume our rover is at one of the moon's poles, which allows us to use the 86-degree frozen orbit mentioned above. The lunar rover will thus be in line of sight for about 0.9 hours per orbit. During the 0.9 hours, when the laser can acquire the target must receive both sufficient laser energy to power the rover and sufficient additional laser energy to store 2.3 hours of power for use when the laser circles out of sight. Assuming 50 watts per hour continuous and lithium sulfur batteries with an energy density of 500 watt hours per kilogram, the surface power storage system would mass a mere 1/10 of a kilogram. The surface system will also need to track the orbiting laser system in both the horizontal and vertical axes. In the worst case scenario, when the satellite happens to be in shadow for the whole time that energy is being transferred, and assuming an ACT lens on the lunar surface is used to focus the beam, we've computed that the mass of a complete system for tracking, receiving, and converting energy would equal about 8 kilograms. What about the mass of the orbiting system? Summing the masses for the total orbiting element of the 50-watt continuous system, we calculate about 45 kilograms. One more power system remains to be addressed, and that is atomic power. Just recently, NASA announced the successful development of what it calls the Kilopower project. This is a miniature nuclear fission reactor that uses a small Stirling closed-cycle engine. In terms of mass to translunar injection, the Kilopower reactors definitely cut the cost compared to other alternatives NASA has proposed. However, there are still some definite drawbacks to this approach. First, they are still massing about 3 times as much as an EML1 and EML2 based laser system. 3 times as much of the same comparable power output. Second, a reactor can't match the ability of orbiting laser systems to move from point to point on the lunar surface, since once they're down, they're down. Third, they are not a good fit for micropower generation. And last but not least, the solar-powered laser systems don't require the use of fissionable materials in space, with all the headaches, politically and otherwise, that implies. That said, there will be places where kilopower reactors will be not just competitive, but essential. For example, on Mars, where solar collectors may be down for significant amounts of time due to dust storms. We can now compare the masses of our proposed systems to the mass of other competing systems. Keep in mind in the following spreadsheets that most systems are being listed as 15 kilowatt continuous delivery on the surface. However, there are several variants of the NASA Kilopower system, which is shown at deliveries ranging from 15 kilowatts down to 0.8 kilowatts. Also keep in mind that these figures are only approximations and subject to change. In our 2015 analysis, we estimated mass to various locations in Falcon Heavy units or FH units. That in turn allows us to calculate the cost to various locations. We now know that the Falcon Heavy can lift 63,800 kilograms into LEO at a cost of $90 million for a fully reusable launch where all 3 cores are returned for reuse. Thus, a Falcon Heavy unit to low Earth orbit costs 1,410 kilograms. For a chemical rocket propulsion from low Earth orbit to lunar transfer, or LTI, which requires about 3 times the mass of the package delivered to LEO, and thus a Falcon Heavy unit, or FH unit, would cost 4,230 kilograms, $4,230 per kilogram. And from lunar transfer injection to the lunar surface, which is also about 3 times the mass of the package delivered, a FH unit would cost about $12,690 per kilogram. We've also calculated that using electric propulsion to move from low Earth orbit to translunar injection, we require about a 30% increase in the mass of the delivered package. That is to say, electric propulsion could do the job for much less. In Falcon Heavy units, that delivers a package to translunar injection for $1,833 per kilogram. If we assume that the 180 kilogram lunar rover would be part of the total package launched, the mass of the lunar rover in orbit would equal 540 kilograms, including the rockets to land it and the fuel. The total mass in lunar orbit would thus equal 585 kilograms, including the lunar laser orbiting satellite. Assuming chemical rocket propulsion at 4,230 kilograms, the cost to launch the lunar rover and its laser power system to lunar transfer injection would be about $2.5 million. Assuming electric propulsion from low Earth orbit at $1,833 per kilogram, the total cost to launch the lunar rover and its laser power system to lunar transfer injection would drop to about $1.1 million. Alternatively, if we assume that we're only launching the orbiting laser system and the surface system is already built into a customer's instrument, the FH unit cost to orbit a 45 kilogram laser power system at lunar transfer injection with chemical propulsion would be about $190,000. And assuming electric propulsion, the cost would drop to $82,500. So there you have it. If you view the micropower step as a precursor to the low power step, and so on up the power scale, we believe that we found a way to grow the seeds of a lunar power utility, or LPU, with an exceedingly small but well-placed investment. In a way, you could say that by selling power through the lunar night, we're proposing to sell moon miners the equivalent of blue jeans, picks, and shovels. And as anyone who's read about the old California gold rush knows, in the long run, it wasn't the miners and prospectors that made the real money. It was the merchants that sold the miners what they needed so they could go mining in the first place. Thank you very much.
Thank you, Joe, for a wonderful presentation. I'm sure your presentation would have definitely enthused many questions amongst the students and other people. Shall I take a few questions? Hello, Joe, can you hear me?
I can.
Yeah.
Can you hear me?
Are there any questions from the audience? Yeah, please, can you come now? Yeah, I would just like to again repeat, Joe is wearing a shawl and a pagdi and a garland because I had a privilege to felicitate him as the Chair Assembly President when we had attended International Space Development Conference.
Namaste.
In Los Angeles in the month of May. And I had specially requested him to get those things with him. Thank you, Joe. Thank you. Yeah, now the questions.
Good evening, sir. My name is Aditya, and I'm sure you must be familiar.
Pardon me?
I'm sure you must be familiar with the quantum mechanics experiments, especially with the LHC that recently happened in 2014. As you said about space settlements today, is it possible that the experiments like LHC and particle accelerators, can they be built on exoplanets or even on the moon so that they don't risk human life directly?
That's an excellent, excellent suggestion. I believe you are correct. I believe we do need to move any potential dangerous experiments off the planet's surface. And in fact, one of the really major reasons to develop the resources of the solar system is to reduce the amount of resources we go after on the Earth. In effect, we can reduce pollution on this planet. We can increase the wealth of this planet. There's nothing but positives. So your suggestion is a good one.
And so I also have another question. What you showed today was the statistics did by the analyst. But all of us have a feeling in us that if this could happen or that could happen. What do you personally suggest about space settlements?
Well, as I've attempted to make clear, I believe that the beginning to make this work is to go to the moon and stay there. And I believe that we have the potential to use solar energy in orbiting laser systems as proposed by your countrymen and countrywoman that I work with, that is Avinash and, Akhil and Krishna. They propose using lasers in space, and I think it's a wonderful idea, and it will open up the whole prospect of using the lunar resources and indeed the resources of the whole solar system.
Thank you, sir. Thanks a lot.
You're very welcome.
Any more? So, all those who want to ask questions, please come here.
Yeah, we've got about 9 minutes until our chapter's assembly begins.
Hello sir, Namaskar. Myself Master Anurag Mishra. My question is it possible to build or make atmosphere on any another planet like Moon or Mars?
Wow, that's a good question. And I have read futuristic stories about doing exactly that. It's not easy, and I would suggest it must be done with great care if we ever attempt it. The one that I've normally heard speaking about is Mars. Of course, we don't know whether, for example, there is proto-life on Mars. And we should always put first the needs of our scientific community and our knowledge base. So I would not be in favor of trying to build an atmosphere on Mars at this point. And with Mars, there is another issue, and that is Mars doesn't have what we have on the planet Earth. It does not have a very large magnetic field. And I tried to make clear that it is exactly that magnetic field that allows life to flourish on this planet. If we didn't have it, we would not be here. There is no magnetic field on Mars, and there never will be. So it can never become Earth-like. Just keeping that in mind.
Okay sir. Thank you.
Hello, sir.
Hello.
My name is Varnika, and my question is that we spend a lot of money in finding about exoplanets and their atmosphere and the things which are needed for them to be habitable. But why don't we use the money to make the preparations to make the closer planets habitable, like for example Moon or Mars?
Okay. I believe you're right about Moon. The Moon is our sister satellite and very much our next door neighbor, literally. And I believe that the Moon is a perfect place for us to go. Now, that said, the Moon is subjected to radiation in space, cosmic radiation from all directions. And you can only have life on the Moon and indeed on Mars underground. So even if you could give it an atmosphere, it wouldn't be good enough. You would not be able to survive as a family or as farmer or anything like that. It's all going to have to be done underground. That's not an impossible task, but it does need to be done that way. Does that help?
Yes, thank you.
You're welcome.
Hi sir, it's Ishwari Joshi and I am 13 years old and in 7th standard. I want to ask you the question that all the technology and communication is based on the satellites which ISRO and NASA is launching. So whenever you are launching, are there any crashes whenever you are launching the other satellites?
I'm sorry, you'll have to repeat your question.
Means the communication and technology is based on the satellites which you have launched already. So that satellites are already orbiting the Earth. So whenever you are launching the other satellites, so is there chances of crashing the satellites?
Of crashing.
Huh?
In other words, orbital, what we call orbital debris. In other words, in orbit right now, we have all kinds of junk. And that junk is actually relatively dangerous. As you say, you can crash into it. If you crash into it, you're going to create chunks of more junk. And we had a wonderful movie, I don't remember the name of it, where a space station literally was destroyed in orbit because of orbital junk. It's getting worse all the time. It's a huge issue. And in lower Earth orbit, we are inside of our magnetic envelope, so we're safe. However, it's like pollution. We're not going to be safe if it's polluted. The problem is everybody in the world is trying to get up there, and there are no rules. It's every man for themselves, every woman for themselves, every person for themselves. We need to make rules, and the world has to agree to them, how to deal with this major, major issue. Thank you. Well, wonderful question.
Thank you, sir, for spending your great time with us.
Yes.
Good evening, sir. Myself, Dinesh Chaudhary. My question is that what does the most recent research say about the possibility of part or current microbial life on Mars?
Microbial life on Mars, and what is the present possibility of it? Is that correct?
Thank you, sir.
No. Did you ask me? I'm trying to clarify. Did you ask me what the present possibility of microbial life is on Mars? I think that's what you asked me.
Yes, sir. Yes, sir. Yes.
Okay,
So,
good. Thank you.
So another question is, sir, what do
By the
NASA
way,
scientists
the
and
answer
ISRO
to your
scientists?
question, your first question, I don't know.
Yes.
Okay. Second question.
Sir, which countries generate the most utility scale solar power in the world?
Repeat that.
Which countries generate the most utility scale solar power in the world? Solar
I'm
power
sorry.
station.
Which countries are using solar power the most
Generating
or in the world? Pardon me?
solar power in the world.
Yes, the solar power worldwide is growing in use. Presently, I know that China is doing a great deal. Obviously, the United States is doing a great deal. I believe India is making great strides in the use of solar power. But solar power, to really become useful, needs to be sent from space to the planet's surface. We need to create effectively solar farms in space. And we know how to do that, but it's going to cost an enormous investment. Again, it's like the problem with orbiting debris. It affects the whole world, and the whole world has to step up to the problem. So the United Nations, for example, would be an excellent place to start a dialogue on how to build solar power plants in space that can project their energy to the surface of the Earth and help everybody everywhere.
Okay. Thank you, sir.
You're very welcome. And it looks like we're about out of time, so I'm going to have to probably call a halt to this.
Good evening, sir. Myself,
Yes.
Dev Sandeep Pangane. My question is, sir, what is a supernova?
Wow. A supernova, technically speaking, is one of the biggest explosions possible in the universe. And I'm not going to get into the technical ramifications except to say it's an exploding sun. Our sun, obviously, is the source of energy and power and life in our solar system. But there are suns out there that are much, much bigger than our sun. And at a certain point in time, due to either situations with other bodies or just the natural evolution of that sun, they collapse upon themselves. Their gravity literally pulls themselves inward and creates an extremely huge burst of energy. And literally, for the moment that that sun explodes, it outshines the complete sunlight of every star in our galaxy. And it produces enormous amounts of cosmic radiation. And that radiation travels forever throughout the universe. And it comes from every direction. It's why outer space is so dangerous. And we didn't really know that until we started getting out there into outer space. Thank you. Good question.
Thank
and
you,
I really
sir.
have to stop because we got to get going on our chapter assembly.
Yeah.
So-
So take care of the time because other people would be joining now. It's almost
That's
7:30 here.
correct.
Yeah.
Hi, sir. My name is Piyush
it's this-
Patel.
Hey, Avinash,
Yeah.
hold on a second. Avinash, it's now 7 o'clock here. So this is the time we were to start our chapter assembly.
So shall I close it?
I think we need to close
Yeah.
it and move on.
Maybe in our chapter assembly, these boys would get a chance to
I
speak
hope
to
they
the
do.
people.
The people that are up there can ask questions.
Yeah.
Listen, they should listen to the chapter assembly and prepare a question for it.
Yeah.
But thank you for all your wonderful questions, audience. It's just my pleasure to listen in. And I'm not sure I did a great job answering them, but I did my humble best.
Thank you. Thank you, Joe, for a very lucrative and informative session you had just now. And we expect all the people who are joining here from all over the world, they would definitely throw more light on the advances and adventures in space. So, shall we
Right.
switch over to our chapter assembly?
Yes. Now, one of the people who was supposed to be here
Just see how many have joined.
was supposed to talk briefly about the National Space Society.
Yeah.
And unfortunately, I don't see them here.
So many people have already joined.
I'm going to probably go ahead and just quickly talk briefly about the National Space Society and explain what it is. Very brief.
Jamie is there. Christine is there.
So
Grace is there.
I'm the chair of the chapter assembly of the National Space Society. And the National Space Society is now a worldwide organization dedicated to promoting humanity moving into space. That's what the National Space Society at its core is all about. The society itself was formed in 1987 by merging of two space advocacy organizations, the L5 Society and the National Space Institute. And my particular chapter, the Sacramento L5 Society, was one of the early chapters there. Another thing that that the National Space Society does is it holds a yearly convention called the International Space Development Conference. And they are the principal sponsor for that event. And every year it's held in a different city. And it's been held, for example, in other parts of the world. I believe it was a couple of years back that it was held in Canada. And a few years before that, it was held in Puerto Rico. So we hope that in the future we can have international international space development conferences in cities throughout the world. So NASA is the principal sponsor for that, and it's basically a gathering of experts on space that is open to the general public. And it is occasionally, as I said, held outside the United States. So that's one of our big things that we do. Another thing that we are very much involved in is in contests. So National Space Society, for example, is funding a space settlement design contest that is open to high school students from any part of the world, including your folks there. And they should all take a look at getting involved in that particular contest. Another thing that the National Space Society is involved in is political action. And for example, the International Space Station grew out of a vote in the United States Congress that passed by a single vote, one vote. And yet, as a result, we did, in fact, build the International Space Station, the ISS. So that's part of the reason that we get involved politically, although it's very prescribed. And finally, the National Space Society has developed a space settlement roadmap that can be found at our new website, which is space.nss.org, and which creates a roadmap, literally a roadmap to how to move from our Earth into space. And then last but not least, there's the chapter assembly itself. And the screen is filling, as you can see, with various people from other parts of the world. And these people are, in fact, many of them chapter members. And therefore, the chapter assembly, in effect, is a democratic institution, because each of these people, each chapter can send a representative to a chapter assembly. Now, in the past, our chapter assemblies have been physical. We've actually gotten people who come to an International Space Development Conference, and that's where they meet. However, as of the last couple of years, we've started doing virtual chapter assemblies, like, for example, what's happening today. So you, members of the audience, are literally looking at a chapter assembly live and going on before your very eyes. So, in effect, you are guest audience members of our chapter assembly that we try to hold once a month. Now, in a chapter assembly, what we usually try to do is arrive at aspects which are going to be universal and which effectively many of us can agree is a need or a requirement. So today, in our chapter assembly, one of the things we're going to try to do later on is to discuss the theme of the World Space Week, which is Space Unites the World. And we're going to have a live discussion about that. And hopefully members of the audience can participate in that discussion. So the next thing on the agenda, however, is going to be introductions from other people besides myself. And what we're going to do is we're going to basically go down the list. And I'm going to start actually with Avinash, who represents the chapter assembly, the chapter in your city in India. So Avinash, could you just give us a very quick summary of your chapter, what it tries to do? And obviously we see part of it in this very event, which is a wonderful event. But would you speak just for a few minutes about your chapter and what it's up to?
Yeah.
You're on.
Yeah, thank you, Joe. I'm so happy to welcome all these dignitaries, all these stalwarts of space industry. I see Claire. I didn't see Larry. I didn't see Cleopatra. I think they may join later. They may join later.
We have a couple of phone numbers that are here,
so
and people can join by phone
Yeah,
in
I
our
see
chapter
Perry.
assembly.
Yeah.
So we
I.C.
will
Krishna.
double check
Anyway,
when they show up.
So,
Who is
this
on those phone numbers?
World Space Week 2018 is being celebrated in Nashik by Maratha Vidya Prasarak Samaj, which is 104 years old, one of the biggest educational institutions in our state, as well as one of the best in the world, in India. And they have more than 200,000 students, and they really serve the tribal and rural areas where other people generally don't want to go. Since all these people who were real visionaries in the past, they established this organization, this institution, and they have been carrying out in a very democratic way. So we have the Secretary General of the institution, Mrs. Nilima Tai Pawar, to say hello and welcome you all.
All right.
Yes, good evening, sir. I,
evening.
General Secretary of this institution, I welcome all dignitaries of NSS, and we all feel proud for this noble work you are doing for society. Again, I welcome you all, sir. Thank you.
Fantastic.
Okay.
Yeah, we had already mailed our week-long program. Every day we have many guests coming and making presentations here and talking to the students. This event, World Space Week 2018, is actually dedicated to the awareness of space technology amongst the students for their career opportunities, entrepreneurship, and setting their goal of future. On 4th of October, that's the first day of the week, we had our director of Indian Space Research Organization, who is in charge of the communication, educational communication unit. Yesterday, we were really lucky and fortunate to have the ex-chairman, the highest officer of Indian Space Research Organization. And for these 2 days, we had wonderful exchange of ideas, future missions, information, and everything. And also, today afternoon, we had interaction with the Dean of Indian Institute of Space Science and Technology. That is the only space university in this part of the world we call Asia. So he had a wonderful interaction with the students, and all the students, they are so enthused. You could have seen the way they are asking questions. There are so many people who are asking questions, are waiting for asking questions. And also tomorrow and day after tomorrow, Monday, I see Shili here. Yeah, you are going to have your presentation on Monday evening. Oh,
Yes,
hi,
that's
Eric. I remember our visit to Houston Space Center in last year. Of course, so I hand it over to all others so that they can introduce themselves and they can interact with our audience also. Thank you so much.
So David, why don't you go ahead and go next?
Okay, I'm David Sheely. I'm the president of the local chapter in Oklahoma. It's in the Oklahoma Space Alliance. Our focus is space, of course, and we're part of the National Space Society. Uniquely in Oklahoma, we have a spaceport in Burns Flat. It's actually a runway that is 90 meters wide and 5,000 meters long. No, pardon me, yeah, 5,000 meters long. So we are ready for horizontal takeoff and landing for spacecraft. And that's one of our key focuses in this area. In my regular job, I'm an engineer for the Air Force. I develop new technologies, which is actually dual technologies. We do repair for aircraft, which transfers to the civilian and the military world, mostly the civilian. Thank you.
Thank you, David. So let's go next to, let's see. Let's go next to Eric. Eric, can you unmute?
Yes. Howdy. I'm Eric Bowen, president of the Clear Lake Area National Space Society and Moon Society chapter in Houston, Texas. The Clear Lake area is home to the Johnson Space Center, which is the nerve center of NASA's manned spaceflight program. It's where the astronauts, the American astronauts, live, train, and work. Our chapter's membership includes several present and former NASA employees and contractors, including a former space shuttle flight controller, as well as several other space enthusiasts, one of whom would be myself. Now, I've never been associated professionally with space, but I grew up in this local area with my dad, who still lives nearby, and he was a member of the Apollo team who ran the simulators that Neil Armstrong and others trained in to land on the moon. And as Tom Hanks asked at the end of the movie Apollo 13, I look up at the sky and ask, when will we be going back? And who will that be? Oh, and by the way, go Astros!
And that's the sports team. So Eric, you want to go back on mute? Thank you. We have a visitor, Teo. I'm going to take you off mute here. And, or let's see if I can do that. There, no. Unmute. Teo, say something.
Good day, everyone.
There you are.
From Nigeria, and it's really nice to be amongst you guys. I feel like I'm the youngest here, but it's great to be able to connect with a lot of people in this space industry. And over here, we've been able to create space societies, basically a student level. But what we're working on with the NSS chapter is getting adults who are interested in space together, to come together, to work together in Nigeria to develop the space sector in Africa, basically. So that's our main focus, and it's an honor to be working with everyone. It's an honor to be here. Thank you.
Wonderful. Thank you so much for joining us. Thank you for making Nigeria part of this international process. Okay, well, speaking of international, we have another gentleman from India, in this case from New Delhi. So Shiv, you think that you can maybe, I'm going to try to unmute you here. There, I think I succeeded. So go ahead and speak to us for a little bit.
Good evening.
Speak a little louder or get your microphone closer. Get your microphone closer.
Sorry. Good evening, everyone. I'm Shiv Sethi.
Hey Shiv, we can't hear you.
Yeah, we can't hear you. Your microphone needs to be closer. You have a microphone? Speak very loudly.
I can hear him over the phone.
Oh, you can hear him over the phone? Thank you, Claire. Yeah, for some reason your volume is really low.
Sorry about that.
Just speak really loud. Shout. I mean, almost shout. Literally, yes.
Okay. Till then, let us switch over to other person.
It's okay, Avi. Go ahead. Go ahead, Shiv.
Good evening, everyone. I'm Shiv Sethi. I'm one of the co-founders of the New Delhi Space Society. We're a very young chapter right now. We're about 2-3 months old, and but we have huge plans in mind. And coming up this month, we have a national event that we're hosting participants all over the country, thousands of participants, and it's an honor to be here. And I would like to thank all dignitaries present here.
Wonderful. Thank you, Shiv. So, Shaksham, I see you're on also, and you're also from the New Delhi Space Society. Could you speak with us a little bit?
Yeah, sorry.
Perfect. You're much.
Yeah. Yeah. So I'm with Shiv here. So I'm the president and the co-founder of the society. So as he said, we're a really young chapter, and rather we're college students, and we're just really passionate about space. We've been extremely passionate about space since school. So like the competitions you mentioned, NASA Ames, which NSS is now funding and organizing. So we've been for those competitions. We've been to ISDC, and we're really passionate, and we just want to share that with our community here in New Delhi. Yeah.
Wonderful. Thank you so much for being with us. All right, it looks like Jamie, is that you, my friend?
That's me.
I see you in two, I see you were actually up twice. I have another connection, but don't worry about it. Just, I can hear you now. So give us a little rundown on your chapter and what you guys are involved in.
Okay. The reason I'm on two different things is because my computer camera and my audio didn't seem to want to work, and now it's working and I can hear myself echo. I'm a member of Genesis, which is a San Francisco chapter of the National Space Society. I am personally involved with space habitat, and most specifically, I'm interested in one of your previous questions this morning at the conference about microbial life on Mars. I'm currently taking a class in fungi and learning about it on Earth, as well as going to be repeating my presentation that I gave in St. Louis on Earth fungi off Earth. This has a lot of ramifications from everything from contamination, living environment, and also in the food and waste areas of space travel and habitation on distant worlds. So when we leave here, we have to make sure we don't take any unwanted guests. And when we get there, we want to make sure that we don't introduce unwanted guests to a sterile environment.
Great. Thank you so much. All right, so you can go back on mute there, if you would.
Okay.
And then I see the next on the list here is Bruce. Bruce, do you want to unmute and speak to us a little bit?
Yes, hello. I'm Bruce McKenzie, live in Boston, northeast corner of the United States. I was active in running a chapter for many years, but more recently I founded the Mars Foundation. It's an affiliated group with NSS. I'll be talking to you Tuesday. And I still am active in the NSS Chapters Committee, doing some internet support. And let's keep moving quickly.
That's okay. Thank you, Bruce.
Yeah. Hello, Bruce. Hello, Bruce. Do you hear me?
Yes, I can hear.
Yeah, we had a wonderful rehearsal today morning, and you are going to make a presentation on Tuesday on living on Mars. So, welcome to this.
Yep.
Please.
All right, so Phyllis, I see you're there. Do you want to go ahead and speak to us briefly?
Yes, thank you. My name is Phyllis. I'm a space enthusiast and chapter president for the National Space Society of Arizona. And I'm host also for the local Moon Society. First, I'd like to express our gratitude to Nashik India chapter and President Avinash and the Kalpana Youth Foundation for inviting us to celebrate World Space Week with our fellow chapters and outposts today. Like our other chapters, we focus on creating a spacefaring civilization through educational outreach. Our current initiative is expressed with our open monthly speaker meetings, created to allow people to learn and interact with space experts and hear about their current projects and research. I also get to host a small workshop on satellite tracking for kids and make paper satellite crafts at some conferences. Some of our coming projects are Yuri's Night, the Space Up Conference, and support for VR for Good. We also are planning participation in Comic Fest, which is kind of unique. It does host a science panel division that includes NASA scientists and other industry experts. We also provide members with a voice for legislative advocacy on space. We get to connect with local space leaders who are willing to share their latest breakthrough in space exploration and development. Our recent outing was with our local university for ASU, the Congressional Conference for Space Innovation, which provided our members an opportunity for us to listen to members of the Arizona Congressional Delegation on several space topics and their opinions. Our members also have an opportunity to ask questions that allowed candid discussions and answers on different aspects for space advancement and roadblocks. I think this conference also provided Arizona's space industry to bridge the gap between Congress professionals, providing ideas and concerns and information. Also, we were honored earlier this year by an invitation from our Arizona House Majority Leader to have discussions about space and aerospace topics in Arizona. A few of our members had an opportunity to visit and talk about and initiate projects that they have a special interest in, and also to have follow-up meetings and to continue these discussions. So it also gives us an opportunity to provide a visual of our NSS members here in Arizona. And we are grateful for these kind opportunities and the ability to be able to follow up with our House Majority Leader. I'm grateful for our NSS members here in Arizona who demonstrate their dedication to space. I also want to express my gratitude and thanks for being a part of NSS and to be of service. I'm also grateful and honored to represent NSS Phoenix. I find enjoyment in watching and helping others succeed and celebrate their achievements. It is my continued hope that we may be able to influence and make an impact on an individual basis and to keep our mission strong. I believe in this work because it matters and it makes all the difference.
Fantastic, Phyllis. Thank you so much. So you can go back on mute for now. And there's a gentleman, all I can see is I and M. And I'm not sure exactly who you represent. Yes, raise your hand. And who are you?
I'm Michael Stenneken. Do you hear me?
Oh, yes, Michael, from Germany.
Yes, from Germany. I'm this year. Read it in the right way. Yes.
Very good.
Yes.
Wonderful. And that is coming up when?
German Space Society. You can read German Space, Deutsche Raumfahrt, German Space Society. And our motto is exploration, we do it for the Earth. I know your motto is to create a spacefaring civilization. And we think our emphasis is most of us will not go into space. The Earth belongs to space. And for most of them, it's like in the Bible, in the Old Testament, the space is a firmament. You see the bright light and the small light and nothing else, most people. And I think my personal history, to see in the background a collection I began in the age of 8, when this year was, then I was 9. And I began to collect all the paper articles and I attached them to posters to show them in schools and so. And I the pupils a vision. I am this year in the age of 9. I was a carnival costume as astronaut. And in this, I printed this picture by a pen to this linoleum cut, like this here. You can make prints like this here. So, and this print from this, finally, this photo here. 30 years later, I present to the original man, Buzz Aldrin, and this was my 39th birthday, the same age Aldrin was in space, on the moon. And this was in the year 1999 in the Lunar Base Development Conference in Houston. And 1 year later, we founded, this time I had the NSS PR Bureau Germany, by Karen Mermel initiated it. And then we founded the Expo 2000. Expo is a space fair in Hanover. I don't find the sheet, but it's not important. And I think we do it for the Earth. The most benefit for Earth is education. And in the age of 9, 10, it changed from the elementary school to the higher school. And in this age, you must create a vision for your life. And Werner von Braun was so a man, he got his vision in the age of 13. He was failed in mathematics, and he read this book from Hermann Oberth. And I showed the pupils, the students, the small kids, this book and the great vision Hermann Oberth developed. And then the pages, I show them this here and say, what is that? And they say, oh, it's extraterrestrial language. He says, this extraterrestrial language is mathematics. And if you want to reach something in your life, you must learn it. And this is a motivation for the kids. And the special thing is we have now a new ISS commander, Alexander Gerst. I met him 8 years ago during a conference in Berlin. And he has doctorated in geology. And I asked him, what was your subject for your doctorate? And he said me, what happens in the first second after a volcano eruption? Oh, I said, that brings you into space. I know Thomas Reiter, there was the first German on ISS. And he decided, same age like me, about when he saw the lunar landing, I want to go in space one day, but what I have to learn? I must get a combat pilot in the Air Force. And this is Alexander Gerst. He hadn't anything to do with Air Force and such, only to learn his geology issues. And so I say the children who ask me how to become an astronaut, I say them, do what you want, but do it right, in the right way, in the proper way. And then you can use it for space one day. And they are motivated to do their own things, to find their personal moon in their lives and use the space to sharpen their own skills. Because in aeronautics, you must be perfect. Good is not enough. The difference between good and perfect is like heaven and hell. You see it in Apollo 1, Soyuz 1, Challenger, Columbia. One mistake, they were dead. And that is my personal emphasis in our society. And the others have their own. We let them choose freely. We accept housewives, they're interested in Teflon pants and so they can look for the personal benefits of space exploration for their own lives, whatever they do. And there we stand for. And everyone can change our homepage, every member for his own interests. And my interest is education because we have 5 children and had temporary additional 2 foster kids. And when they were in school, every class, I teach them one lesson in our space school. And that's in Astra was an article, and that is what I'm personal for. And another thing you must, I have time a little bit, is that the history of space exploration, especially Germany. Therefore, I got a space historian. You know that Werner von Braun, the first rocket in space, it was 71 years ago now. And there was a company there. My grandfather was a classmate. You know him. I have a book from Albert Speer memories. He wrote it in prison, his memories, and there's a chapter where he proposed Werner von Braun as a professor. And my grandfather studied with Albert Speer, an architect in Berlin back then. Had nothing to do with him later. It was before the bad time. But since then, I'm interested, how can the evil become normal? And that maybe a little bit can explain the children nothing to the same error again. And an example of Werner von Braun, he turned the evil to good, to land on the moon. So far.
Thank you so much. What a wonderful speech. Okay, I'm going to ask you to go back on mute. Do you know how to do that, or can I do it for you?
Yeah, thank you very much.
Okay, I'm going to put you on mute. Okay, next we're going to hear from Christine Nobby. Christine, can you unmute and speak with us?
Yes.
Yeah,
I can figure
you
out
said
how
something?
to unmute myself.
You got it. You're there.
Yeah, I can
You're
even
there.
start the video maybe too. Hi, so I'm Christine Nobby from St. Louis, Missouri, and I would like to point out that St. Louis is the home of human spaceflight, American human spaceflight, because we built the Mercury and the Gemini capsules that put the first American astronauts into space. So I always like to point that out. So our chapter is called St. Louis Space Frontier. We were around in the 80s and the 90s, and then took a little nap, and then reformed in 2013. And one of the goals for reforming the chapter was to host the International Space Development Conference, which we did in 2017. Several people I think on here probably were there, but not everyone. And our chapter is really busy doing as much outreach as possible, communicating with people all around the community about space exploration and space settlement. One of our members is definitely on, Chris Jensen. So, and I can't tell from phone numbers if anybody else is on, but a couple of people were interested in joining today. So Chris, do you want to say hi?
Yeah, go ahead and unmute, Chris. Or I can do it for you.
It takes a minute.
There it goes.
All right. Yeah, this is Chris Jensen. As Christine said, I'm part of the St. Louis chapter and an NS member, and just dropped in to see how this whole thing works here, and yeah, a strong space advocate and all that.
Well, welcome to our little chapter assembly.
Yes.
Okay, Christine, you want to finish up?
Yeah, and I don't know if there's anybody else. If they are, maybe you could raise your hand, because there's some phone numbers that I can't tell who you are, because some people said they were coming today. I wanted to say hi to Eric. Eric said his dad worked at McDonnell Aircraft on the Mercury program. So excellent, glad to know that. You're always welcome to St. Louis, everybody. If you're here, please let us know. We have regular presentations at various locations, and we're always looking for speakers. So if you're going to be in St. Louis or in the area, let us know, and we'll find a place for you to talk to people about your love for space. So thank you.
Thanks, Christine. So there's a gentleman named Donovan Martin. Donovan, would you like to unmute and talk to us briefly?
Hi, Joe. Hi, everyone. You're speaking to Donovan Martin. We are quite a recent new chapter. We were inaugurated at your ISDC this past May, and what an opportunity! What an exciting event! So thank you for hosting that stunning event. It's really appreciated. Then what I have to say then is we actually have, in fact, our president at the Cape Town Space Society, which we are known as, is Professor Hal Walker, who's also a member of the OASIS chapter in LA. And many people don't know, but Professor Walker was directly involved with the Apollo 11 mission back in the early 60s. And what they'd done was actually create the world's first ruby laser for measuring or instrumenting the distance from the Earth to the Moon. So together with Buzz Aldrin at the time, they positioned the reflector to actually get the correct instrumented distance from the Earth to the Moon, which is great. One of our members as well, who's recently joining the Cape Town Space Society, happens to be Dr. Andy Bluffer, who back in 2004, from South Africa as well, and based here in Cape Town, basically did the instrumentation measurement for the Mars Curiosity rover, believe it or not. So way down south from Cape Town, we've actually got something to share with the rest of the world, so quite exciting. And what we've decided to do as the Cape Town Space Society is basically focus on space transportation. When in fact, when we were at the ISDC in May, we had a student contingent of 3 students who actually presented their ion propulsion drive. And we had quite an audience with the unit. And if I may, I'd like to share my screen with some images.
Certainly.
To show what. Thank you.
Give it a shot. Hit the share button and let's see what happens.
All right. Can you all see that?
There we go. Yes. Excellent.
Great. So we've got the students from left to right, Skylar Martin, who happens to be my daughter as well. She's quite the one. And then Chantal, and then right on in the center, more or less, is Mr. George Whiteside, who happens to be the CEO of Virgin Galactic. And then we've got Dean on the right. And what you see in the center of the screen is their Ion Drive project, which was actually at the ISTC this year. And quite exciting. It was entirely built. We managed to build all of that within 25 days from start to finish in record time and have it ready for the ISTC. I must say, though, transportation was quite interesting, trying to get that through customs from South Africa all the way to the US and then back again. It was quite challenging, but we did it nonetheless. And in case anyone doesn't know where we are in South Africa, I've got an image for you all. In case you'd like to visit, I'd like to see where we're based. Let's have a look if I've got a great image of SA, if you don't mind. So that's where we are. And we've got an excellent exhibition area. So as you pointed out, Joe, hopefully sometime in the future, we could host an event in our fair city. Who knows when that may be. But what we've also done in the past is that we've actually embarked on our own space program, I think in the early 90s, which was then unfortunately shut down at the time, where we had a complete launch vehicle, believe it or not, and our satellite program. So where we've come from now is we're actually hosting the Square Kilometer Array program. What that is basically it's a radio astronomy telescope, which is the largest in the world today. And it's a collaboration with many, many nations taking part right now. And it's quite an exciting hub of events that's occurring. So that's us. We are a very young chapter, but very excited to be part of the family, the global family, and definitely the universal family going forward. And yes, that's my story in a nutshell.
Thank you very much. So
thank you.
What I'm going to do is I'm going to see if we can turn you off of share. There. You're done.
There we go.
Very good. You have some expertise up here with Zoom. Very welcome.
Thank you very much.
Okay. So we actually have a few more people. I'm going to save Claire till last for a specific reason. But Perry, could you go ahead and unmute and tell us a little bit about what you do with the National Space Society?
Sure. Can you hear me?
We can.
Okay. My name is Perry A. Dutre. I'm an ambassador for the National Space Society in Colorado, and I've been an ambassador for the last 10 years. I'm not affiliated with any particular chapter. I've worked on projects with the National Space Society, the Denver Space Society, and the Enterprise in Space programs to bring knowledge and understanding to senators, congresspeople, state and House representatives, aerospace industry executives, students, and the general public. I've participated in everything from governmental roundtables to industry forums and science fiction conventions. For me, the Space Unites the World topic, I believe that we as a species will need to break down the barriers that separate us. I'm concerned that just yesterday, India purchased $5 billion worth of missiles from Russia to protect themselves from China. Well, a few weeks ago, Russia was flying with China in military exercises. I don't believe that this is any way to unite all of Earth's people. I'm a deep dive researcher, analyst, and writer that focuses on social sciences that bring us together and those that tear us apart. I'm a criminologist that focuses on cybercrime and terrorism. We must have equality for all of the people where there are no caste or gender divisions. Both men and women from any nationality are equals, and it is proper education and long-held traditions that separate us. My goal through life has been to break down these barriers and bring forth actual change for the betterment of the entire human race. And this is the way I believe we must approach taking our species into space. So as an ambassador, these are the things that I try and do. And I'm honored to be here today. That's
Very
it.
good. Thank you, Perry. Can you go back on mute for me?
Sure.
Thank you. So we have two people here on telephone, and I can tell you one number is 1781-944-7027, and the other is 1405-329-4326. I know one is Claire. Which one are you, Claire? Claire? Okay, you're the 1405 number. And that means is the 1781 number, is that Larry?
No, that's Bruce McKenzie. I've got two connections.
Okay, so Larry didn't make it here. He's been having a flaky system. Okay, I'm going to put you on mute just in case. And Claire, that makes you the last person. So I'm going to give you the floor.
Okay, I would like to share my screen.
Yeah, excuse me, Joe. Let me first put my heartiest gratitude to Claire for encouragement, for cooperation, and through Ad Astra, she has put our Nashik India chapter and Maratha Vidya Prasarak Samaj joined together for this World Space Week. Claire, we are so happy and so grateful to you for all your help and encouragement. Thank you very, very much.
I second that. Okay, Claire.
Avinash, I am very impressed with what you have done working with your institute and your chapter. And really, without you, this whole event, which is one beginning of uniting the world, would not have happened, because you were the one who had the vision to invite people from other parts of the world to participate. My name is Claire McMurray. I have been a space enthusiast since I was 3 years old, when my father showed me the stars. And then at 7, I read a book that told, if you could take a rocket through the solar system, here is what you see at each planet. And that was in 1947. So you see, I've been trying for a long time. I wanted to be an astronomer, but I ended up getting my degree in psychology. My father, by the way, he worked for the Space Department, the State Department of the United States. So my two brothers and I, the three of us, were born in Paraguay, California, the United States, and Chile in South America. So it's very natural for me to become the international chapter's coordinator. On the right of the screen, can you see my screen?
Not yet.
Don't.
Have you?
Well,
okay.
What do I have to do?
At the very bottom, it'll say share of your window, and you have to hit that share button.
Oh,
and then you'll have to select. Have you done that yet?
I don't want to exit video.
No. At the bottom of your Zoom window.
Yeah, well, I can't see that at the moment.
You can't see your Zoom video window?
No.
Okay. What do you see?
A minute. Here.
This is the by the way.
Okay, now I can see it.
Okay.
Hello, are you with me?
Yes, we are.
Okay.
Hit share. Let's see what.
Here
There you go. You got it.
Okay, that's.
There we are. We see the International Space Station.
Yes, and I wanted to start over here. Okay. On the right of the screen, you see me back in 2011. My husband gave me as a gift a short flight on a small airplane to experience zero-G and also lunar and Martian gravity. Best birthday present I ever had. And as you see, the disadvantage of a small plane is you can't do very much. The advantage is that's a little more than some of the astronauts could do. I wanted to show you Space Unites the World. There are many North American chapters. I am here with the big blue star, and you all are in Nashik, India, roughly here. And I believe that the New Delhi chapter is up here. We have, my dot for Cape Town, there we are. And Germany up here. We also have a Greek chapter. There are 3 chapters in Australia, and I thought the Newcastle, Australia chapter might be able to send Joe something to show from his screen to participate, but they say that their computer system is not up to the task of truly joining. And I may have missed a few.
Canada, for example.
Oh, Japan up here. So we really are all over the place. Australia did not call in, but we have on the call North America and Asia and Africa and Europe. So 4 continents. I want to go on here. One of the first ways in which space united the world was with communication satellites. And the first one was Telstar in '62. And now we have the 21st century satellites, which are far more capable. They do TV and phone and internet and weather and your finances and the GPS and other navigation, radio, remote sensing, national security, and not national security also. Wait a minute, that's the wrong button. Okay, and we have the International Space Station. Now that is owned by Canada, Japan, Russia, the United States, and the European Space Agency, and the countries that belong to it, which you see down there, quite a few of them. But other countries can send their astronauts there, and in the last few years, once in a while, individuals have been able to sponsor their own trips. If they have enough millions of dollars and enough ability to persuade the Russians to sell them a seat. But I am hoping that as the space station ages and perhaps transitions to private, and perhaps we get additional space stations. I know Bigelow would love to have one of their own. We will have more opportunities for individuals to experience the world this way. But here is really the first time that space united the world in a major known to so many people away. Hundreds of millions of people saw this picture in magazines because Apollo 8 took the picture, but they could not transmit it until they brought the film home and showed it to the public. Earthrise from Apollo 8. Well, you're there. 1868. And that is, I believe, the end of my presentation.
Wonderful. So I'm going to see if I can manage to knock you out, and I'm going to do that by first sharing my screen and then stopping my share, and we're back. So I notice there is another phone number, 1405-329-4326. Who is there?
That is Claire, because my computer will not transmit anything.
Oh, I see.
Yes.
So you have basically two phones going at the same time?
No, one phone and the computer.
Okay, who is 1-720-641-7987?
That's me, Bennett Rutledge, Denver chapter.
Thank you, Bennett.
I'm driving through the western slope, surrounded by the Rocky Mountains, near the western edge of Colorado. I just drove over Grand Mesa, the National Forest, and the leaves are just starting to turn. I've seen all sorts of wildlife, deer and hawks, and some not so wildlife, cattle. Had to drive over some cattle guards to make sure those cattle stay where they belong. And got some awesome mountains surrounding me, which of course cut off my signal from time to time. So don't panic if I suddenly drop out.
Okay, we'll take that under advisement.
What I've been getting from this conversation is that one of the really urgent reasons to get as much as humankind as possible out into the solar system, and particularly to get the heavy industry out of the biosphere, so that someday all of planet Earth can be a historical and wilderness park.
That's a great theory. Go ahead.
I yield the remainder of my time.
No. Please continue. That was a wonderful beginning. There is no yielding. You can talk as long as you want, or not as long as you want, but a fair bit.
Well, I had a discussion with a lunchmate of mine just yesterday about electrical energy and the grid and how to get power without generating a lot of carbon footprint. And one of the things that will help keep Earth in shape enough that it will attract tourists as a historical and wilderness park is to use more renewable energy. Colorado is developing more and more wind farms right now. And of course, a lot of solar power options. But back in the 80s, I was studying some options where the solar power collectors were actually in orbit, not geostationary orbit, but still a geosynchronous orbit with a little bit of inclination so that it doesn't crowd into the orbit that is now at least reserved for the communication satellites that Claire was telling us about. But because the microwave antennas that they use to transmit the energy they collect down to consumers on the surface of the earth are steerable. The antennas to pick up the energy do not have to be as sensitive to the direction of the satellite they're receiving from as a dish network or dish television reception. And another thing I'm looking forward in the next decade or so is the development of mining of asteroids, for example, off planet, where you'll be able to do the really dirty industries in a way that, well, okay, let me just say that the moon is not a dead world. It was never even alive. And what we need to do is take advantage of that and protect the earth by having the heavy industry somewhere besides the only biosphere that we have available at the moment.
And that would be the earth.
Joe,
Yes.
I would just interrupt. Because it's getting late for our students to go home because it's 8:30 here. So, and they have come from a long distance. So they have some questions. They will ask the questions, and whoever would like to answer their questions, it is most welcome. Shall I call the students?
Before you start, Avi, okay? Remember, this is a chapter assembly. So what I wanted to do next is to talk about what we're going to do very briefly, and then we can have your students speak, okay?
Yeah.
And the next thing that we're going to be doing is we're going to be having a discussion on a theme. So I'm going to share my screen just for a minute and show you folks what, in fact, we're going to be talking about.
Okay.
So you should be seeing on your screen now a little document. Says, here is a simple list of possible subjects for a resolution or resolutions under the general theme, Space Unites the World. This is our job as the chapter assembly. We are effectively here to try to create resolutions and or actions which we can then refer upwards to the leadership of the National Space Society for their endorsement. That's what we're here meeting here today for.
Pancakes left?
Pardon me? Okay, hold on. I'm going to have to mute. There we go. What we had there was some interference from somebody speaking. So I'm going to go back here and share this again. In effect, we came up with 5 bullet points, which we feel would be a good point of discussion. So what I effectively want people to do is let's see if we can have a free-ranging discussion and don't take too much time because we've only got an hour total. And as Avi pointed out, we have students that have to go elsewhere. But each element of this list that you see is on a broader theme of international space issues. And think of it as a framework, and which we can add to or refine things on the list. So effectively, what I want us to try to do is to come up with new things to add to this list. So Avi, as your students speak, that's fine. And I'm going to be typing along in the background, trying to see if I can synthesize things to add to this list. So that's the process that we're going to be going through. And I'm going to stop sharing now and give you back the floor, Avi. You're on.
Shall I call them?
Yes, go for it.
Please. Come.
Good morning. Good evening. Good evening, sir. It's Kabir Donde here. I just want to ask that sometime before you asked, someone had asked you a question, and you had told that life is not possible on Mars because it does not have a magnetic field. So why are we wasting money on Mars but not giving that money to find life on many other exoplanets or moons like Europa?
Okay, well, that's a great question. Does anybody want to take a shot at answering him?
Yes, this is Eric from the Houston Clear Lake chapter. I would say that just because we can't live out in the open on Mars, or we can't live unprotected without a magnetic field, doesn't mean that we don't need to spend the effort to figure out how to live in space without the magnetic field. There are other types of shielding. We can shield under mass. We can shield under, for example, lunar regolith. And we need to learn how to live in space and work in space without a magnetic field, or we're going to be stuck just here on Earth for the rest of all time.
Thank you. And Eric, could you unraise your hand? Thank you.
Thank
and
you, sir.
Anybody else want to speak to this question?
Hi, sir. My name
we have another question. Go ahead.
My name is Piyush Patil. My question is, if we settle on moon, then who will govern it?
Would you repeat your question?
If we settle on the moon, then who will govern it?
Then who will govern the moon?
Yeah. Yes.
Well, obviously, that is a great question. We know that in other times past, we went, for example, to a different place in the world. I mean, if you go back to the beginning of history, people started in one small place and they went new places. And as they went, the governments were created for those places. So it's quite possible that at some point in the future, the moon would be its own country. It would be its own nation. And they could literally govern themselves. Does that answer your question?
Thank you, sir.
Great question.
Hello, sir. Sir, my first question is, we all know that universe is expanding. So can we claim that the speed of expansion of universe is more than the speed of light, because light cannot escape the universe?
Okay, anybody want to take a shot at that one? A more technical question? I think you've stymied us. That was a great question, and honestly, I don't have the answer. What do you think? What do you think?
Sir, I don't know. I ask so many friends, but nobody can explain. So.
Okay, we see one person raising their hand, and that's Teo. Teo, you want to take a shot at this? Go ahead and go off mute.
I would like him to come again with the question.
You'd like him to what?
Come again with the question.
Would you repeat? Would you repeat your question one more time for Teo?
Sir. We all know that universe is expanding. So can we claim that speed of expansion of universe is more than a speed of light, because light cannot escape the universe?
All right. So we know the universe is expanding. Can we say that it can't be expanding any faster than the speed of light.
Okay, according to what I understand, with theories of relativity and the likes, it's going to be, it's not practically, most likely not possible to move faster than the speed of light, even for the universe, because even the universe is a very, very large object. Objects that have been postulated to be able to move faster than the speed of light are very, very light and most likely wave-like materials, wave-like particles. So we can say that the universe is not expanding faster than the speed of light. That's what I understand, basically.
Thank you very much.
Sorry, sir.
I'm going to ask you to go back on mute, Teo.
Sir, I can't get answer. Can you explain, Joseph, sir?
Explain what?
The answer again.
Can I explain the answer? He said that the universe cannot go faster than, the universe cannot expand faster than the speed of light. That's the answer.
Sir, I have another one. I have another question. What is the current research going on dark matter?
What is the what?
What is the current research going on dark matter?
Dark matter is a mystery, and nobody really knows what it is. It's still a matter of great research and great interest, as is dark energy. Those are two fundamental forces that we've discovered recently that we're not very sure what it is or how it is or what it's comprised of. There are a lot of possibilities. So the answer is we don't know.
Sir, I have a last question. How to detect gravitational waves?
How do what?
How to detect gravitational waves?
Oh, well, interestingly, one of my chapter's members helped to build an instrument called LIGO, LIGO.
Sir, how
it's
it works?
And LIGO is effectively a laser that is with a very, very long light beam. And it was actually able to detect gravity waves. This is a breakthrough over the last couple of years from what they now conjecture to be two black holes running into one another. It created a huge wave in the gravitational field that went through the whole universe. So when you have this LIGO instrument, and I believe there's one in the United States, and I'm not sure there's another one in Europe or if it's where it is, but there's a couple of them, and they can use those two instruments between them to absolutely verify that we actually sensed a gravity wave. It's a major breakthrough and a very fascinating subject.
Thank you very much, sir.
Good evening, sir. I am Dev Sandeep Angane. My question is, are we alone in the universe?
Okay, who wants to handle this one?
Yes, sir.
Okay, well, hold on a second. Somebody's going to answer. Do I get to pick somebody? Christine. Oh, Jamie. Go ahead, Jamie. Tie goes to Jamie. Oh, Jamie, I can't hear you. Nope, not hearing you. All right.
Hi, folks, it's Bruce.
Oh, we got feedback, Bruce. Go ahead. We lost Bruce.
Hi, can you hear me?
He's back. Go ahead.
Yeah, we have not seen any evidence of intelligent life in the universe, but that doesn't mean it isn't there. They could be hiding from us, or they could be a long way away from us, or for some other reason don't want to let us know. And it's actually rather hard for them to transmit radio waves a long distance. So we don't know, and that's one of the exciting questions that may be answered someday, or maybe we just never meet anybody. But in either case, we want to be prepared. So We don't want to run across any aliens and mistreat them, but we also don't want to destroy our own world on the chance that we're the only life in the universe. So it'll be interesting if we ever find out.
Thank you, Bruce. Christine, I saw you had your hand raised. So do you want to go ahead and say something?
Well, I was going to say a lot of what Bruce just said, that we have not found life in the universe beyond Earth. But I believe, just based on what we know about the universe, that it's probably lurking out there. And I would also like to point out that life as we know it on Earth, it may not be anywhere near the same in another solar system or another galaxy. We can't count on life looking like we know it. So the big question always is, what is life? How do you define life? Will we recognize life if we come across it?
Very good question. And Shiv, I saw you came in with your hand raised. You want to speak?
Yeah. I hope my mic is fine now.
It's not quite as good, so you'll have to speak loud.
Okay. I think I'll just be building on Christine's point. So the question, what is life, is a very vital one to the answer of this question. But I think what I think you mean by life when you ask this question, you must have heard there's a famous comparison which says that there are more stars in our galaxy than there are then there are grains of sand on all the beaches on planet Earth. So, and about each star, there might just be many planets similar to Earth, and I think it's almost a null probability that we are alone. It's almost pompous of us to think that, but
right. Thank you. So I just want to actually just take a little bit of, and you can take your hand down, Shiv, okay? I just want to emphasize a little bit when he says that there are more stars in our galaxy than there are grains of sand on our beaches. Consider that there are more galaxies than there are grains of sand on our beaches. So we're talking about all of our beaches as galaxies and all of our galaxies as grains of sand on all of our beaches. That's an enormous number. To think that there's no life anywhere but on this planet is probably wrong. Also, the universe has been around a very long time, billions and billions of years, and it will be around for much longer after you and I are gone, and perhaps even after our species. So there will be more life to come. We could just be beginning to see how. Now, the question is, the universe being as big as it is, will we ever get to meet that other life? We don't know. That's an impossible question to answer. Thanks for a great question.
Yes, sir. Thank you, sir. Sir, it's Kabir again here. I just want to ask two more questions. That we know that if an object comes near to a black hole, it gets sucked into it and it goes to its event horizon or point of no return. So what happens to the matter?
That is another great question. Anybody want to give an answer to that one? Somebody that hasn't talked yet. Okay, Teo, one more time. Go ahead, Teo.
Okay, answering that, presently there is research going on to confirm what happens to the matter, but Stephen Hawking, blessed memory, has actually postulated a theory concerning Hawking radiation, which is emitted from black holes. So you can say that the matter is emitted in a form of radiation, even though we can't detect it with our own equipment just yet. But they're working earnestly to be able to detect and know what happens inside the black hole. Because presently, when you send light to a black hole, it's unable to escape. So we don't really know what happens inside it, but you can decipher from physical laws and happenings around the black hole what might happen in it. So we don't know what happens to the matter. There is a possibility that Hawking radiation is correct. And there are also other theories that also define different things that might have happened to that matter. So that's just the basic explanation of that. It's a mystery. Even the black hole is still a mystery.
Right. And so go ahead and take your hand down, Teo. I just would add that effectively, because we know that the gravity is still there, we know that the mass is still there. In other words, a black hole contains whatever fell into it. It didn't just disappear from our universe, or we wouldn't see the gravity. So it's still there. It's just beyond what they call the event horizon. That is to say, the point where light can never escape. We can never see what's inside a black hole. Thank you. Another good question.
So I have another question that
All right.
I've read in a book that if you threw a boomerang in space, it would return to you. And after some days, I again read another book, and it was written that you would, if you threw a boomerang in space, it would never return to you, as there is no air in space. So what really would be the answer?
Oh, well, that's an easy one. The boomerang would never return to you unless you were in a curved space environment. What does that mean? Gravity is the weight that you feel that pulls you through the floor, okay, is a force. And it effectively, Einstein proved that actually curves space. So if you threw your boomerang at exactly the right angle and exactly the right speed and force, it could curve around an object and come back on the other side and hit you in the back of the head. But it would take probably quite a long time. You'd have to throw it very, very fast. So in a way, oh, and by the way, air does not exist in space. And the reason a boomerang comes back on the planet Earth is because it curves through the air and it has a wing shape, like an airplane, that is designed to bring it back to the person that threw it. It needs the air to curve and return. Thank you.
Sir, I have one last question that Einstein proved that time and space becomes distorted or curved. So we can travel to time. So does really time and space get curved due to gravity?
Yes, it does, and we do travel through time. That's why this second is not the same as the last second. We're literally traveling through time all the time. But in Einstein's world, time is just another dimension, much like length and breadth and height. And so from that point of view, outside time, everything that has happened and everything that will happen is just one big thing. So time is like one thing. It's connected. It's a dimension. So the answer going back in time is we have some theories that say that with in some ways it might be possible, but nothing that would be remotely like what you hear about with time machines and such. That's not theoretically possible. Anybody else want to add to that?
Thank you, sir, for spending your time.
Okay.
Hello, sir. I am Rushikesh. I have one question about black hole. Why does time warp near event horizon?
I'm sorry, you're going to have to repeat your question.
Why does the time or motion warp near the event horizon?
Why does the time
warps near event horizon?
change near the event horizon of a black hole? You know what the event horizon is? Okay, black hole has a thing called an event horizon. And so if you approach a black hole, in effect, you accelerate. Einstein taught us that when you accelerate, your time is different from everybody else's time. And so when you go towards a black hole, it might look to us like an instant goes by, but for you, it might look to us like an instant go by, but for you, it might be forever. We don't know what happens. We don't know what happens with time in a black hole. But those are the theories. Anybody else?
Okay, thank you.
Okay.
Hello, sir. My question is, does organisms exist on the sun?
Oh, can an organism exist on the sun? Who wants to try that one?
Thank you.
Let's see. Jamie, you want to try it? Let's see if your mic works.
Our questions are over. Now we can
Okay,
go
I'll
ahead
try
with
it.
our business.
Sure.
Go ahead.
An organism as we know it, back to our previous discussion about what is life, most likely cannot, simply because the ability for atoms and or particles, which could comprise life, are in too violent emotion due to the heat of the sun. So unfortunately, life probably couldn't exist on the sun.
At least not as we know it. I mean, who knows what weird possibilities exist on a gravitational and electromagnetic spectrum level.
Once you get into other dimensions, anything's possible.
Anything's possible. Okay, Avinash, did you want to say something? Avi? Avinash?
No, I don't want to say anything about what the students have asked, but now one thing is there, that this particular program has really created awareness amongst the students in space technology, about National Space Society, and what's happening all over the world in the area of settlement on Moon and Mars and beyond in deep space. So it's a great achievement. Of course, the 5 days are yet to go, and we will have many more questions and many more answers by the learned people. And this particular chapter assembly has given a great opportunity to our students to listen to the space experts, and also you have got an opportunity to see what type of space awareness has been created in India. The little children, 6th standard, 6th grade, 7th grade, and even less than that, yesterday to our chairman, one student who was just 4th grade student, he asked questions, and everybody was really impressed by that. So that's the whole thing which is being done and which will be done in future also. Thank you.
So Avinash, I just want to thank you for having set this up. I'm going to echo what Claire said, that this all happened because of you. We would not be here. You were the person who basically lit the fire. You may recall the conversation that you and I had at ISDC when I was regretfully forced to tell you I could not travel to India this year, but that I would try to be there virtually. Well, guess what? Here I am.
But next year, when we meet in Washington for ISDC 2019, definitely I'm going to invite all of you to visit India. Next year, this year it was virtual. Next year it will be in person. So well, this is my invitation, and you are going to accept it.
That's been great fun. Thank you for your input, and thank you for the input of your kids. So we have another half an hour to go before this chapter assembly is scheduled to end. So at this time, I'd like to try to turn the discussion, if you please, again to the subject of a possible resolution. So I'm once again going to share my screen and bring up the list of the resolution here to remind everybody what it is we're talking about. So here I go, sharing. And so what you should be seeing in the middle of the screen there is some verbiage. So just go ahead and let me quickly read the possible subjects for a resolution right now, whether or not we can get to a vote, whether we can add to this list, and so forth. So the 5 that we have right now, and by the way, the audience is welcome to stay or go and listen to the rest of this chapter assembly. The first possible subject was the statement, reaffirm our commitment to the National Space Society vision of people living and working in thriving communities beyond the Earth and the use of the vast resources of space for the dramatic betterment of humanity. The second subject, work to ensure that the continued growth and development of the nascent, that means just beginning, the nascent cislunar economy will provide dramatically better living standards and security for all Earth's people. The next one, work towards building cooperation on solving the problem of space debris. The next one, work towards developing a general consensus within the chapter assembly and the National Space Society on space-related legal issues such as property ownership in space. And finally, work towards establishing a lunar decade honoring mankind's first steps on the moon 50 years ago. So the first thing I'm going to ask is people's impressions of these 5 comments, and bearing in mind that we would like to focus on the broader theme of international space issues, whether there's something you feel we could add to this list of possible resolutions. And the floor is now open to anybody who wants to speak. Wait a minute, I'm going to stop the share and see if there are any hands showing. Jamie, it looks like your finger's moving.
There you go. I do have something to mention, and that's specifically about the legal issues. Back in 1972, I did a term paper in aviation law on space law. Since then, I have found the active community who are investigating the rules, regulations, and statutes of space law is alive and well. There is even a Facebook page. There's a website that's dedicated to anybody and everybody that wants to be involved in the legal issues of space. As back in the day, we were just looking at space and not the moon. But since then, they have separate entities that go on to other heavenly bodies.
Okay, so basically you're emphasizing, I guess what I was looking for was whether or not this is a statement that we can form into a resolution, or as part of a more general resolution that people could support, or that they would have problems. Any one of these statements. And anybody want to raise?
What I was trying to get at is, we as a National Space Society would probably do well not to try to reinvent the wheel.
Okay, so here is the statement as it's written. Work towards developing a general consensus within the chapter assembly and the National Space Society on space-related legal issues such as property ownership. So basically, the idea is maybe broader. That is, that in the chapter assembly, that is in this body, we can discuss and try to arrive at a general consensus on aspects of space-related legal issues. So I guess more than, to my mind, that's not a problem. I think we could probably do that. You're saying that it might be just reinventing the wheel, but I can guarantee you that reinventing the wheel is the way we learn new stuff. If we don't reinvent the wheel, we won't find the new wheel.
I understand. Let's take for an example, you have two spacecraft that run into each other in low Earth orbit. And one of them is the International Space Station, and the other one is somebody from Russia or Japan. Where is the tort claim to be resolved?
Well, in that case, the International Space Station is partially owned by Russia and partially owned by Japan. Both of those countries. Let's say it was China that ran into it, and you might have a little bit different situation.
Well, these are the questions that space law, at some point I can find the institute. I believe there is an actual foreign body, not foreign body, but there's a body out there that is a clearinghouse for all legal issues off Earth. Okay.
So the question is, again, Jamie, can we, as a chapter assembly, agree on some basic legal issues? And I mentioned property ownership as one. You mentioned space collisions as another. In fact, there's this kind of ties in with another of the objects on here, which is the subjects, which is work towards building cooperation on solving the problem of space debris. That literally is another big subject, and and in fact, during the meeting, a young man stood up and specifically asked the question, "What are we doing about space debris?" So anyway, I see two more hands. Shaksham Arora, go ahead and you have the floor.
Hi, thank you, Mr. Brand. So I just wanted to add to the topic that you just came on here, that is space debris. So I've worked on a concept, rather on a paper, and I'm trying to get it patented on like a concept to remove for active debris removal. So I feel really strongly about orbital debris, and I think it's like the single most or the biggest problem that the space industry has currently, and it's only bound to go worse. And you mentioned if there is anything that any of us might want to add, I would say I would rally against the militarization of space with President Trump's, remarks about Space Force and all those things. So, militarization of space would be really catastrophic, even though I can understand that there are satellites for national security and surveillance and all that, but I really think that weaponizing or sending satellites, weaponizing space, as we've seen with China, shooting down their own satellite with a harpoon, which has led to even more debris. I think all these issues that we're talking about here, legal issues with space, orbital debris, and something that I just mentioned, militarization of space, are all interconnected, and I would love to see NSS work towards that.
Okay, very good statement. Anybody specific? I see there's many hands up here. So whoever, let's see, I'm gonna start with Teo, because we don't hear often from these people. And Teo, try to answer a little bit on Saksham's comment about space debris and militarization and how debris is created. But then if you have something else that you want to say, go ahead and speak. So Teo, you have the floor.
Okay, thank you very much. First, I want to talk about, I'm going to talk about the space debris, but first I want to talk about inclusion of developing countries in space programs. It's no news that most developing countries are quite sidelined when it comes to policy making concerning what happens in space. Only the big giants and the spacefaring nations have been able to do such. I'm not saying that younger countries, developing countries should make the primary decisions, but they should be given a chance as well to participate in decision making in space exploration activities, because this way it will ensure that we are able, because Nigeria as it stands is a developing country, to ensure that we are able to foster and promote the young minds in Nigeria, such that in the future, Africans can also get an opportunity to explore space. And concerning space debris, it's more like I believe it shouldn't be just policy. It shouldn't be the agencies alone that should worry about space debris. We should think about harnessing problem-solving strategies from private sector, from students, from young professionals. This way, space debris, we can get a lot of ideas that can help eliminate the hazards of space debris all over.
So you're saying, Teo, when you say it shouldn't be from the large, countries or corporations?
Yes, I believe space debris should be a problem for all. So corporations, countries, agencies should come together to solve this problem. And you never know, when you crowdsource for information, you get a very brilliant idea that can actually help eliminate space debris. We're working on a space debris mitigation spacecraft here in Nigeria in my school. But presently we're trying to source for funds to make a minimum viable prototype that we can show to the world, to let them know that, okay, space debris can be removed. We can remove it without destroying this debris. We can bring them back to Earth and recycle them. That's basically the focal point of our research. So there are other ideas out there. And I believe if government can sponsor people bringing ideas, pushing the ideas forward, we can solve the problem of space debris together, because space belongs to all. And if we are to protect the future of space exploration, if we want to keep going to space, we need to eliminate that problem as soon as possible. Thank you.
That's a very, very well put statement. And let's see, Teo, take your hand down, please. Anybody else? Okay, I'm going to take a minute and I'm going to bring up again these bullet points. I'm going to share it here, and we can look at them again and see what we've got going. So we've had some comments, for example, on working towards building cooperation on solving the problems of space debris. And we've had some comments on space law. Can we speak to, for example, this idea of working towards establishing a lunar decade, honoring mankind's first steps on the moon 50 years ago? And I would just point out that literally the 50th year anniversary is next year. And so this might be the most appropriate time for us to endorse the idea of a lunar decade. So could I get some comment from people on this concept of establishing a lunar decade? Hands? Or just speak out? Anybody?
Hey, sorry, it always takes a while to get unmuted.
Not a problem.
This is Christine. Let me see if I can also figure out how to start my video again. The talk.
Uh-oh, we just lost her. She'll have to re-enter the session. That's unfortunate. Anyway, too bad we don't know where she was. But again, back on the question when she comes back on of establishing a lunar decade. Claire, I know that this was something that you proposed. Do you want to comment on it? Claire, are you with us still?
Yes, I'm still with you.
Could you comment on the concept of a lunar decade?
This would be a year in which, not a year, a decade, 10 years, in which science projects and other kinds of projects would be aimed at learning more about the moon, and possibly also on the whole relationship between the Earth and the moon scientifically. The moon has a lot to say about how the Earth was formed, and the Earth has a lot to say about how the moon was formed. But they're not, obviously, it's the same thing. They are our closest other heavenly body of any size, whatever. And we really need to know more about it. And certainly, if we're going to use any of the lunar resources, of which there are many, especially, well, aluminum is one of the biggest ones, but one of the most useful from the space point of view is the water that appears to be on the moon. And we definitely need to know how much water there is, whether it's water that can be extracted or it's just hydrogen atoms that are included in some other material. We need to know these things.
So
and it's an important part of a potential space economy. But I did want to say also that there are 4 African countries that own satellites. One of them is Nigeria. And I believe that Nigeria may be, let's see, well, I don't see that at the moment. Ghana was the first African country to indigenously develop a satellite. And, but various African countries have partially built or completely built or gotten somebody else to build a satellite for their own uses and someone else to launch it. And now that we have somewhat lower launch costs, we should be able to offer more opportunities to developing countries. I would also like to say that the United States, not the United States, the National Space Society has already established many, there's a whole section of the positions of the National Space Society that has to do with the fact that we do believe in the possibility of legally owning property in space. We're generally for it as a society. There is a treaty which space developing nations have not signed that says you cannot do that. But there's also a treaty which space developing nations have signed that says that the nation that launches an object into space is responsible for damage that object does. And I'm not positive whether that only means when the object comes back to Earth, meaning that it's dangerous to Earth space debris, or whether it would include damage that object does to other objects in space, in which case I don't know where it would be adjudicated, but there's definitely a rule that says we accept responsibility if we launch something.
Yeah, okay. So, but back on the question of lunar decade and what you mean by it, it sounded to me like you were going to propose a lunar decade. as an actual, something that the chapter assembly and the National Space Society would basically sign off on and support. And by lunar decade just simply means that we want a decade where this would be the lunar decade where we concentrate on doing things regarding the moon. Is that a fair summary?
It's similar to other decades that I forget what the first one was.
Okay, but that's a good point. It's similar to other decades that the UN, for example, has supported or underwritten.
Yes.
Okay, good. So now I see that. Where is she? There? No. Justine, there you are. Go ahead and speak, because I'm sorry we lost you. But you managed to find your way back.
Yeah, I did. I don't know what happened, but Zoom crashed.
Oh my gosh.
So the lunar decade. The point is that right now people are really focused on the moon. Really think, okay, the Dear Moon ambition from SpaceX and the Moon Village that European Space Agency is focusing on, plus involving many other people. People are focused on the moon right now. It seems like National Space Society and our chapters should also be focusing on that. What exactly we would be doing, I do not know. But if we're going to really have a settlement on the moon, it is going to take a lot of people and a lot of effort. And I just think we should get on board.
I love that. That's a great summation. Anybody want to comment on Christine and Claire's sort of definition of what we mean by lunar decade? I see Perry. Perry has her hand up.
Yep. I agree with Christine in focusing in that direction. I think that the National Space Society, a group of us or something, should concentrate on the treaties through the United Nations that are already there and work to bridge some of those gaps between different countries and possibly even update or some of those treaties a little further. It takes decades to change people, and it takes, as you know, with legislation and law and on, it takes many, many years. So if we were to start looking at some of the laws and treaties that have already been signed through the United Nations, since that's pretty much the organization, worldwide that unites all of us or tries to. I think that would be a wise start. I wouldn't mind helping with that. So that's it.
Okay, well, thank you, Perry, and take your hand down. Perfect. All right. We can get input from other people. Avinash, I noticed you have some visitors up there.
Yeah.
Who do we have?
Yeah, I would like to take this opportunity to introduce our team, particularly the people from the Maratha Vidya Prasarak Samaj, the educational institution. With their help only, we could achieve what we have achieved up till now. And of course, our World Space Week would be celebrated with these are the backbone of the whole program. So I would just request is Dr. Kazale is an education officer of that 104-year-old educational institution. And he is in charge of all the colleges, the education, and all other things. You have seen him in the last meeting, is Dr. Om Prakash Kulkarni. He is a renowned scientist working in solar industry, and he is our secretary of Nashik India chapter.
Hi, Joe.
Hi.
Hello. You have seen him at Los Angeles.
Hello.
As Vijay Bhaviskar is treasurer of National Space Society, but also he is heading by name Kishore International School for the children from 1st standard till 12th standard. That is grade in USA. So he is in charge of that. And though we are a very small team, but we are working together in cohesion and trying to get a success with your cooperation and your encouragement and the best of the best suggestion that on this occasion you had conducted a special chapter assembly meeting. That's a great thing. That's a great thing. And Claire very rightly has said that it is unprecedented. It had never happened before, but on the occasion of Nashik chapters program, you people were kind enough to join us. Thank you so much for all your encouragement.
Thank you.
Well, we get more out of it than you guys, let me tell you. And thank you. Thank you all on your end that have helped to make this happen, including the technicians who, as I sat there and wondered where that sound was coming on, and we worked on that for like half an hour, and it was from me. It was my problem all along. If we hadn't had your technician and a smart one that finally figured that out, we would have been here for long hours. So we depend on our technology, and I think that this has been a testament to the future of technology. I hope everybody here shares with me the feeling that this has been a success, that this whole effort to try to bring people from many different places, to give everybody a voice, and to reach out in common to everybody, sort of a group hug, as we would put it, in a virtual group hug. I think that's an important thing, and I think we pulled it off. I'm very pleased. Anybody want some last minute statements? We have about 5 minutes till the end of our session. So if anybody wants to raise their hand and say something, this is a great opportunity. But thank you all for helping participate in this, and thank you all for having made this a success. So go ahead, raise your hand, or just turn on your mic and say whatever you want.
Bye-bye. And good night from India, and of course, good morning in USA.
Thank you, Avi.
Okay. Thank you. Bye-bye.
Bye-bye. So anybody else want to speak? They can speak. Or are we tired? I guess we're all tired. Okay, well, we're a little bit before 9 o'clock, but you know what? That's 9 o'clock here, which is 9:30 p.m. in Indian time. I think Avi probably needs to go have a nice dinner somewhere and relax, because he's got a lot more work to do. So, folks, unless we have an objection, I'm going to call this meeting to an end. I think it's been very successful. And thank you, folks, once again. Anything anybody wants to add?
So, David, see you on Monday.
Okay. Bye-bye, folks. We're ending the meeting.
Bye.
Oh, well.
Leaving.
Okay.
आता याच्यात कुठे नव्हता करायचं आहे नॅशनल अँथम मला नाही वाटत काजळे सर राष्ट्रगीत म्हणायचं आहे नाही नाही नको